What we're going to learn today is the equation of a line in standard form. We have been graphing all of our lines so far. They've been in slope y-intercept form. Everything we've seen looks like y equals 2x plus 3 or something like that, and that has been a pretty common equation of a line that we're used to seeing. There's a different order of the terms that we can use, and it's called standard form. So the x term would come first, the y term would come second, and then the constant number would be the third item. It goes in this order every single time, and then it would equal 0. So if you can imagine shoving all of these terms over to the left, there wouldn't be anything left here on the right-hand side, so it would just equal 0. Compare the following two sentences. The Beatles wrote several big hits, or a number of big hits were written by the Beatles. I'm hoping you can kind of see that those are saying the same thing, but they're written in a different way. So that's the same idea as what we're going to do with these two different equations. They're just going to be, it's going to be the same line, it's going to be the same equation, but they're just written in a different order. So for example, let's say we had y equals negative 2x plus 3. If I move this negative 2x out here to the front, remember if it's a negative on the right, it's going to be positive on the left. And if I move the positive 3 over here to the left, it was positive 3 and now it would be negative 3. So if I put my 2x in the front, the y is already there, and then the 3 is now negative because it's on the left. I have moved everything over the equal sign and nothing is left here on the right hand side, so it would just be a 0. These are the exact same equation. This would give you the same line on a graph. This is called standard form, and this is slope y-intercept form. So I'm hoping you can see it's actually the same thing. So there are a couple of rules though for standard form, and it's all about this term that's out front. So this term that's out front is really important. It's always the x term, and we call that, this too would be called the a value. Whatever is in front of the x has to be positive. So it's not really proper to leave your equation with a negative 2, for example. You would want to either divide all of the terms by negative 1 or multiply all of the terms by negative 1, because we want to make sure that first term is always going to be positive. Also, the a value, so we want it to be positive, and the a value should not be left as a fraction. So I'm just going to show you, it's kind of sad, they don't really care about the y value and they don't really care about the constant at the back. It's all about this first term. So let's look at example 1. Express in proper standard form. Okay, when I see this, this is not proper standard form. The x is first, the y is second, so that's great, and the constant number is third, and it equals 0. It all looks good, except this first term can't be negative. So one option would be to divide all of the terms by negative 1. And you might be thinking, like, why are you allowed to just do that? As long as you, whatever you do to one side of the equation, you do the same thing to the other side, it's allowed. So when I divide all of these, what happens is actually the signs all change. I get a negative 5y, a positive 10, and 0 divided by negative 1 is just 0. So now I'm happy. This is called proper standard form. The first term has to be positive. Like I said, we don't even care that the 5 is negative. Nobody cares. It's just this first term here, this a value, that 2 is positive. So this one is done. Same with this. All of the terms aren't on the left side, so I'm going to have to move the 14 over. So let's just do one thing at a time. Well, if it was a positive 14, now it's a negative 14. But then I'm also not happy here because I have negative 3. This first term can't be negative. Another way that you might like to do this is just imagine multiplying all of the terms by negative 1. So maybe this would be less work. When I multiply all of these terms by a negative, what happens is they all flip signs. So some students I know, when you get the hang of this, you're just, oh, I'm just going to write that as a 3x and a positive 2y and a positive 14, because 0 times negative 1 is also just 0. So really what we can do is flip all the signs. and this would be our proper standard form equation. So sometimes we just some students will do this. They'll say, okay, I'm going to multiply everything by -1. I know that, dividing everything by -1, sometimes you like to kind of save time, and we just flip all of the signs. Here we have a typical y equals mx plus b, so this is slope y-intercept form. What we would do is move all of the terms to the left. Put the x out front, the y is already there, the 1 becomes negative, and it equals 0. That is proper standard form. The -4 becomes a +4, so we're happy about that a value there being a +4, and that one's done. Here again, there's a couple things we have to do. So I want to move the x term out front. I want to move the -3 to the other side. So remember that every term has to change operation when it moves. The y didn't go anywhere, so don't change its sign right now. It's still just plus y. The 3 becomes positive and it equals 0. So now there's a couple of things wrong with this one. This a value can't be negative and it can't be a fraction. So I don't know, do you want to do our little trick like this? We're just going to multiply the entire line by -1 every single term. So this one flips to a positive, the y is now negative, the 3 is now negative. But we don't like the fraction, so what can we do to get rid of the fraction? So one way to eliminate that is if I multiply this by 2, this first term, these 2's would cancel. So I would just end up with 1x or just x, and that would be great. No fraction at the front. You're not allowed to have the a term be a fraction. So if I multiplied this term by 2 to cancel out that fraction, I have to do the same thing to all of the terms, right? I'm not allowed just to do that. So I'm going to have to multiply all of the terms by 2. So this becomes -2y and -6, but then 2 times 0 is still just 0. So now we have proper standard form. Example 2, what if we were going the other way? What if we wanted have our equation look like slope y-intercept form? We want to have y equals mx plus b. Well, it's kind of a useful skill to take this equation and write it in the form that we're used to for graphing, because this is the form that helps the most with graphing. So when I look at this, I would leave the y where it is, and I go back the other way. I'm going to move the x to the right and the -4 to the right. So that would become -x plus 4. And that would be okay, because this just means the slope is -1/1. So I'm happy about that. That looks like y equals mx plus b, and these are the ones that we know how to graph. The y-intercept is 4. We'd go down 1/1. This is what we like. So here, what if I leave the y term where it is? So always do that first. Just leave the y term where it is, and it's positive. Move the x over so it becomes negative. The -8 on the other side becomes positive. But we're not done, because we want y equals mx plus b. We don't want 2y equals mx plus b. That's not the equation. So we would have to divide all of the terms by 2. And the reason we do that is so that these cancel out. So y equals -x/2 just means the slope is -1/2. That's down 1/2. If you can divide, please divide. So 8 divided by 2, a lot of students will just leave it as 8/2. Like, why not just make that 4? 8 divided by 2 is 4. If it divides evenly, then divide. If that was 8/3, I'd probably just leave it as 8/3. But 8 divided by 2, yeah, just divide it. Make it more simple if you can. Here, be careful here. The -3y stays negative. Just leave the y term where it is, but it's negative. Move the 2x to the other side, so it becomes -2x. Move the 12 to the other side, so it becomes -12. So when I see my equation at first here, just notice like the y-intercept isn't actually 12. This doesn't really tell me a whole lot about how to graph this equation. When I finally get this into y equals mx plus b form, then I'm going to know how to graph it. So because I had a -3 beside the y, I need to get rid of it. So I want to divide everything by -3. So sometimes you have something like 2/3. Well, I can't do anything about 2/3. I like 2/3. That's a rise and a run, up 2 over 3. But the two negatives cancel each other out, so I would much rather you just write it as 2/3 x, and then negative 12 divided by negative 3, two negatives, so that becomes a positive. 12 divided by 3 is 4. Here the y is negative. Be careful, that is negative. Leave that y term where it is. Move the x to the other side and move the 5 to the right. So they both change signs when that happened. Because that's negative, I can't leave it like that. So I want to divide everything by negative 1. So that's a positive y now, because it always has to be y equals mx plus b. Negative 4 divided by negative 1 is just 4x, because two negatives make a positive. 5 divided by negative 1 is negative 5. So we're trying to make these look as simple as we can. Example 3, graph the following equations. So if you're asked to graph something, and a lot of students will be like, okay, so look at this equation. I don't know how to graph it. So when I look at this, I want to write this in the way that I'm used to seeing these equations. So slope y-intercept form would look like this. Negative 2x plus 6, y equals negative 2x plus 6. So then I know how to graph it. Okay, so 1, 2, 3, 4, 5, 6. I know that's my y-intercept. Down 2 over 1, down 2 over 1. I can actually graph this line because I rearranged it. So some students will ask me, am I allowed to just rearrange it? Like sometimes it won't tell you this. It won't say to rearrange it. It'll just say graph this. So graph this equation. I would rearrange it always to make it look like something I'm familiar with. So there's y equals negative 2x plus 6. This one over here, it'll just maybe say graph this. Okay, I would like to graph it if I could see what y equals mx plus b looks like. So I leave the y where it is. I move all of the other terms over, and they change signs when they come over. This is negative y, don't like that. Got to divide everything by negative 1. So I get y equals 3x, positive 3x minus 4, because 4 divided by negative 1 is negative 4. Now I know how to graph it. 1, 2, 3, 4. Go to negative 4, up 3 over 1, up 3 over 1. And there's y equals 3x minus 4. A couple more. Okay, so a lot of students make this mistake. They think, oh, I'm going to go to 6. Okay, watch what happens though. When I leave the y where it is, and then I divide everything by negative 2, you have to be really careful with your integers here. I get positive 2x plus 3. The y-intercept is 3. So jumping to the conclusion that the y-intercept is 6 is going to mess you up a little bit. The y has to be alone. Then we see what the y-intercept is. Then we would go up 2 over 1. And that's y equals 2x plus 3. This one, the y-intercept is not negative 15. So I've had students right away say, negative 15 is not going to fit on my graph paper. It's like, oh, wait a second though. If we leave the y where it is, we move the 10x to the other side, we move the 15 to the other side. I'm changing all the signs as I go, right? Divide everything by 5 because the y has to be alone. So I'm getting negative 2x plus 3. So you didn't have to have 15s on your graph paper. This only goes up to 3. So y-intercept is 3 and then down 2 over 1. And there is y equals negative 2x plus 3.